Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. In this session, we are going to discuss about non-preemptive priority-based scheduling algorithm, shortest job first scheduling algorithm, and preemptive scheduling algorithms. First, for this session topic, we need to follow the Introduction to Embedded System by Shibu KV textbook. In the previous session, we have discussed about different types of non-preemptive scheduling algorithms. Those are first in, first out, and last in, first out. Non-preemptive shortest job first scheduling algorithm. Non-preemptive means a new process get the CPU after completion of the currently executing task only. Suppose different types of processes are available in the ready state, which are waiting for CPU. The currently executing task is completed, then only a new process get the CPU means enter into the running state. Next, shortest job first scheduling. SJF means shortest job first scheduling, means the process which have the less execution time, that process is scheduled for execution first. Okay. Example, I am taking three processes P1, P2, P3 with estimated completion time or execution time 10 milliseconds, 5 milliseconds, 7 milliseconds. A new process P4 with estimated execution time 2 milliseconds enter into the ready state after 2 milliseconds of starting the execution. Okay, this is the consider. So let us consider there is no process waiting for resources or waiting for in the blocked state. Okay, in that point of view. So we already said that ready state, running state, completed state, and waiting or blocked state. At the time of 0, three processes P1, P2, P3 enter into the ready state. In the order, first P1, next P2, next P3 at a time. So among these three processes, if you draw the diagram, 0 at a time. This is non-preemptive shortest job first scheduling algorithm. So at the time of 0, three processes enter into the ready state P1, P2, P3 with estimated execution time 10 milliseconds, 5 milliseconds, 7 milliseconds. Among these three processes, which process is having less execution time? That is scheduled for execution first. So P2 having less execution time, that is 5 milliseconds. After 2 milliseconds, P4 enter into the ready state. P4 enter into the ready state. But it is non-preemptive scheduling algorithm. Non-preemptive means after completion of currently executing task, then only a new process will be scheduled for execution. So, first complete the P2 execution. That execution time is 5 milliseconds. After 5 milliseconds, again, the scheduler checks the ready state. So in the ready state, what are the processes available? P1 is available, P3 is available, and P4 is available. So among them, which process is having less execution time? P4. So that is scheduled now. P4. That's execution time is 2 milliseconds. Next, at the time of 7th millisecond, what are the scheduler checks the ready state with what are the processes available in the ready state which are waiting for CPU. So P1, P3. So among them, which process is having less execution time? That is P3. That execution time is 7 milliseconds. So total 14 milliseconds. Then at the time of 14th millisecond, the scheduler check the ready state. What are the processes available in the ready state? Available process P1 only. So that is scheduled for execution. So the execution time is 10 milliseconds. So total 24 milliseconds. Okay. Now calculate the waiting time and turnaround time for each process, and also calculate the average waiting time and average turnaround time. First, waiting time for process P1. The process P1 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 14th millisecond. So P1 waiting 14 milliseconds. 14 milliseconds. P1 is waiting 14 milliseconds in the ready state. Next, waiting time for P2. Waiting for CPU. P2 waiting time is, so the P2 is entered into ready state at the time of 0 and it is scheduled for execution at the time of 0. So 0 milliseconds. Next, waiting time for CPU by the process P3. P3 waiting time. So process P3 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 7th millisecond. So it is waiting 7 milliseconds in the ready state for CPU. Next, waiting time for process P4. Process P4 enter into the ready state at the time of 2nd millisecond and is scheduled for execution at the time of 5th millisecond. So the total waiting time is 3 milliseconds. So average waiting time is equal to sum of all these waiting times by 4. That is 14 plus 0 plus 7 milliseconds plus 3 milliseconds by 4. That is 24 by 4 milliseconds. So finally 6 milliseconds. So the average waiting time of this scheduling algorithm for this requirement is 6 milliseconds. Next, turnaround time for process P1. Means the process P1 enter into the ready state at the time of 0 and its execution is completed at the time of 24th millisecond. So total time is 24 milliseconds. Similarly, turn around time for process P2, that is equal to, so P2 is entered into the ready state at the time of 2nd millisecond and its execution is completed at the time of 7th millisecond. Total its time is 5 milliseconds. Next, turn around time for process P3. So P3 is entered into the ready state at the time of 0 and its execution is completed at the time of 14th millisecond. So total time is 14 milliseconds. Similarly, for process P4, P4 enter into the ready state at the time of 2nd millisecond and its execution is completed at the time of 7th millisecond. So total turnaround time is 5 milliseconds. So average turnaround time for this requirement is 24 milliseconds plus by 4 milliseconds. So 48 by 4 milliseconds means 12 milliseconds. Average turn around time for this requirement. So like this, for this requirement, check all these parameters and decide which scheduling algorithm is suitable for particular requirement. In this manner, we can decide which scheduling algorithm is best for particular requirement. Next, non-preemptive priority based scheduling. Non-preemptive means after completion of currently executing task, then only a new process is scheduled for execution. Priority means while process is created, we are assigning the priority to the each process. Among them, which one is highest priority, that is scheduled for execution first. Ready state, running state, completed state. Okay. So non-preemptive means after completion of currently executing task, a new process is scheduled for execution. Until that, it is waiting in the ready state. Priority means which process having highest priority, that is scheduled for execution. Let us consider some example. I am taking 3 processes P1, P2, P3 with estimated execution time 10 milliseconds, 5 milliseconds and 7 milliseconds with priorities 3, 0, 2. A new process P4 with estimated execution of 2 milliseconds and priority 2 enter into the ready state after 2 milliseconds of execution. Means after execution is started, after 2 milliseconds the process P4 is scheduled for enter into the ready state. Now, at the time of 0. So, the real-time kernel contains scheduler, that is scheduled ready state always, and decide which process is scheduled for execution. So, at the time of 0, 3 processes enter into the ready state, P1, P2, P3. First P1 entered, next P2 entered, next P3 entered. Among them, here scheduling algorithm is non-preemptive priority. So, which process is having highest priority? Here we are considering 0 is highest priority, 3 is the lowest priority. So, process P2 is having highest priority. So, that is scheduled for execution. Since it is non-preemptive, until its completion, then only a new process is scheduled. So, at the time of 2 milliseconds, P4 enter into the ready state, just for remembering. Next, P2 execution time is 5 milliseconds. Next, after 5 milliseconds, again the scheduler check the ready state. What are the processes available in the ready state? So, at that time, P1 is available, P3 is available, and P4, sorry. Here, this priority is 1. So, P4 is priority, highest priority, so that is scheduled for execution. Its execution time is 2 milliseconds. Since it is non-preemptive, after completion of P4 only, the scheduler check the ready state for scheduling the process. Next, at the time of 7th millisecond, the scheduler checks the ready state. What are the processes available in the ready state? So, P1, P3. Among them, which process is having highest priority? P3 is having highest priority. Its execution time is 7 milliseconds. So, its execution completed at the time of 14th millisecond. Again, check the ready state. So, what are the processes available in the ready state? P1 is available here. So, that is scheduled for execution. P1 execution time is 10 milliseconds. So, its execution is completed at the time of 24th milliseconds. Now, you will calculate the waiting time for each process and also calculate the average waiting time. Similarly, turnaround time. First, waiting time for process P1. Process P1 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 14th millisecond. So, process P1 is waiting in the ready state up to 14 milliseconds. Similarly, waiting time for process P2. P2 is entered into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 5th millisecond. So, it is waiting 3 milliseconds in the ready state. Next, waiting time for process P3. P3 is entered into the ready state at the time of 0 and it is scheduled for execution at the time of 7th millisecond. So, total 7 milliseconds it is waiting in the ready state. Next, waiting time for process P4. So P4 is entered into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 5th millisecond. So total waiting time is 3 milliseconds. So average waiting time of this requirement in this scheduling algorithm is waiting time for process P2. So average waiting time for this requirement in this scheduling algorithm is 6 milliseconds. Next, turnaround time for process P1. So P1 is entered into the ready state at the time of 0 and its execution is completed at the time of 24 millisecond. So total turnaround time for this process P1 is 24 milliseconds. Similarly, turnaround time for process P2 is equal to P2 is entered into the ready state at the time of 0. Its execution is completed at the time of 5th millisecond. So turnaround time is 5 milliseconds. Turnaround time for process P3 is equal to P3 is entered into the ready state at the time of 0 and its execution is completed at the time of 14th millisecond. So total turnaround time for this process is 14 milliseconds. Turnaround time for process P4 is equal to, it is entered into the ready state at the time of 2nd millisecond and its execution is completed at the time of 7th millisecond. So total turnaround time for this process P4 is 5 milliseconds. So average turnaround time is equal to sum of all these turnaround times by 4. So average turnaround time for this requirement in this scheduling algorithm is 12 milliseconds. Like this, for any requirement, we can calculate the average waiting time and average turnaround time based on the scheduling algorithms and compare all scheduling algorithms. We can decide for particular requirement which scheduling algorithm is suitable. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.